Okay, so if I go to the Visual Studio and did I do a little bit of operator overloading with you guys in last time or no? Let me see, CS 440. Fall 2015, right? We did indexer test in university. Okay. So anyway, let me quickly create a operator overloading project. So if I go File, New Project, okay, Windows Forms application, and let me go to browse to our 440 directory. CS440 fall 2015. Okay, and suppose this is OP overload project. And Windows Forms application, C#. Okay, so once we click, okay, so then let me right click on name of the project and add a new class. So right click on name of the project, add class. Okay, so I'll create a simple case over here. So suppose it is currency.cs. Okay, so now let me just put $8, and then right click on it, refactor encapsulate field. And delete the space. And sense. Right click, refactor encapsulate field. Okay, and then currency. Currency left hand side. Currency right hand side. Alright, so now we will do a simple, let me call it currency result. Equal to currency and cents equal to LHS.cents plus RHS.cents. And result.cents is greater than 100. Or let me just leave it as greater than 100 for the time being. And in that case, result dollars equal to left hand side dot dollars plus right hand side dot dollars plus 1. And then rest.cents equal to rest.cents minus 100. And then else lastly return the result. Okay, so just like we discussed, this is our code for the operator plus, right? So at first it seems correct. Anybody can spot what mistake I made over here?
Greater than equal
Yes.
to.
Is greater than equal to, right? So if we test it, for most cases it will come out correct. Remember, as we discussed, that it's always a good practice that you provide an override of the toString method. So if we do public override string, oops, this string,
There's a boot.
Boolean.
string, and then if I double click on it, it will write the signature, right? So over here we can do something return a dollar sign plus dollars dot toString plus plus cents dot toString. Okay. So anyway, so now let's create first just a simple of our own, not a unit test, but our button test. So if I go to the toolbox, go to the all Windows forms, double click on a button. Okay, so now okay, let's just call it BTN test 1. And a text property of test 1. Okay, so now if I double click on the button, okay, let me create currency C1 equal to new currency. Let's say, I didn't put a constructor over there, right? So let's go add a constructor. And as we discussed, typically we put 2 constructors, right?
Yes.
So we will put public currency. Remember, the constructor has the same name as the class name. So this is our default constructor. If you recall, the minute we provide a constructor with our own parameters, the default constructor is taken away, so you have to write the default constructor as well. So public currency, let's say in dollars, and this dot dollars equal to dollars, and this dot cents equal to cents. This dot cents. Okay, so anytime we use this keyword, remember that means it will be using the field inside the class, correct? And this one is whatever is coming as a parameter. Okay.
So do we have to check the data entered in dollars and cents as well? Like if somebody enters like negative cents and positive dollars?
That's a good idea. Let me talk about that in a second. Okay. The answer is yes, and I'll show you what's the good way to do it. Okay. So anyway, now let's go to the form 1. If I double click on the button, it will take me to the button handler, right? So now we can create some currency. For example, what did we say? $5.30. And currency C2 equal to new currency, let's say $8.80. All right. And then currency C3 equal to C1 plus C2, and let's say a lesser box dot show C3 dot toString. Okay, so if we try testing it, Well, what answer do we expect? $14.10, right? So if I run it, and if I click on the button, so you can see it seems to be correct, right? Okay, but like I said, there are many, you guys already have spotted the potential problem over here, right? So, so that's why we do unit testing, where we create many tests. So we will create a test where we do simple addition, like $5, $20, $6, $30. We'll create a test where one of the cases exceeds the cents amount, right? We'll create a test where one of them is 0. We'll create another test where both of them are 0. So all possible variations, we create a test, then we run the test, and then tomorrow the idea is, even if somebody made a change, we will run the unit test and verify that it indeed is producing the correct answer, right? Okay, so let me give you first concept is, okay, see, if you take a look over here, we have a solution, and solution has one project in it, right? Some time ago I had hinted to you guys that a solution in Visual Studio can contain many projects, okay? And why do we want more than one project in a solution? Of course, one example is like we may want a test project, and okay, so for example, we may have a regular project and a test project, right? So e.g. Okay, so what's the benefit of putting both a regular project and a test project? Okay, the projects in a solution can be easily debugged together. So for example, if we created some kind of a test project, and suppose the test is giving us wrong results, right? Of course, we have to go fix the problem. So how will we know what the problem is? If both the projects are part of the same solution, then we can easily go and step through it and find out what's wrong with it, right? So to discuss that now, how do we add one more project to the solution? There's a couple of ways, okay? First way is you right-click on the solution, and then you say add new project. See, to a solution you can add more projects, so it will not give you the option to add a class or something else, right? So right-clicking on the solution, you can pick a new project to be added, okay? Or the other option is, if you have not a professional version of Visual Studio, sometimes it may not give you this option. So if this option is not available, go to the File menu, and then instead of saying New Project, choose Add New Project. Okay, so either one of those options. So, okay, so it doesn't matter, both will end up in the same result. So let me right-click on the solution, Add New Project. Okay, so once I add a new project, okay, so let me see, there should be project. They keep changing this and every. Oh, yeah. unit test project, okay. So yeah, sometimes you have to look for it depending upon the version of the Visual Studio. So we'll create a unit test project, so you'll see. Hey, so anyway, under Visual C#, there was our test type of project. So, so anyway, once I pick unit test project, now you can give it some kind of a name. So let me call it OP overload test. And let me, rather than putting it in a subfolder, I will backspace out of here so that it goes into the fall CS440 fall 2015 folder. Okay, so once I click OK, so this will end up creating a test project. Okay, so as you can see, what it did is, okay, so over here, so this is our test project, and this is our operator overload project. So now the solution has two projects, right? So this is one project, this is another project, right? And it already added a class called unit test 1. Okay. We can name it something else. So if I right click on it and rename it, so suppose I call it unit test currency as an example, because that's what we are trying to do, right? So we'll give it a meaningful name. So we'll ask us to rename everywhere that it's referenced, so we'll say yes. Okay. So then, so typically what we do is, in the test project, this is called attribute. And attributes are one of the very neat things about C#. So as we go further, I will show you what attributes mean and how do we create our own attributes. But for right now, if you can remember, the class, the test class has to be marked with an attribute. So the line above within square brackets, you have to say it is a test class. Then inside it, you can have many test methods. Each test method has to be marked with an attribute called test method. So that's a requirement, right? Now you can call it anything you feel like it. So for example, you can call it test, let's say, operator plus normal. So normal values like $5, 20 cents, and so on, right? So, okay, so now what we'll do is we'll trigger the operation. We'll trigger the operator plus. So of course we need to create the currency object, right? So as soon as I type currency, you will see it's not being recognized. Is it okay? Yeah. Okay, so the currency is not being recognized. Okay, why it's not being recognized? Because where was the currency class declared? It was declared in a different project. We are writing the code in a test project. Okay? So first thing we need to do is, in the test project, we have to let it know that it can access the classes or any other fields or any other forms or whatever declared in some other project, right? So how can we let this know it can access something somewhere else? Let me give you one concept first. Okay. So for example, anytime we compile our project, okay, the classes we create are converted to IL code, right? Remember in the beginning we discussed IL code is the intermediate language code, so very similar to like the Java bytecode, okay? Okay, and once we convert to an IL code, okay, so further the IL code for all classes is put into a file called an assembly. Okay, so an assembly can have an exe or a DLL file extension. So depending upon the type of project, if we are building a library, it will be a DLL. If it is, let's say, a regular application, then it will have an exe extension. Okay, so for example, suppose I right-click on OP overload and do set as startup project, right? Set as startup, and I run it. So or I say build solution. So I build solution, so meaning I'm triggering the compilation. Okay, and of course it's complaining about somewhere, semicolon probably in the test project, okay. But if I minimize this, go to my computer, go to the C drive, go to the CS440 fall 2015 folder, we just created this OP overload project, right? If I further go into the OP overload folder, you'll see there's a bin folder, there's a debug folder, and somewhere over here, do you see, where did it go? opoverload.exe, the top file, okay? So this is the assembly. It contains the compiled code for all the classes that we created in the OP overload project, right? There's also, you'll see opoverload.vshost.exe. Okay, that's strictly for Visual Studio. That's not the assembly we are interested in. We are interested in this particular assembly. Okay, so now once the code is compiled in an assembly, okay, think of it as if it's put inside a box. Okay, so for you to be able to see inside the box, you have to be, the classes themselves have to be declared public. If the classes were not declared public, they will stay inside the box. Nobody outside of that assembly box can access them. And to show you that, okay, so if I go back to our OP overload. Okay, so first, how do I tell the test project that it can access the assembly of another project? Okay, this is what we do. You right-click on whichever project you wanted to allow access to another assembly. So you right-click on it. Okay, one of the options you will see will be, where did add go? Add and add reference. Okay, anytime you say add reference, that means you are trying to add an assembly to your project. Okay, so if I say add reference, okay, so now it gives me a lot of options. In our case, because we are trying to access an assembly that we created, so we will go to the browse button. Okay, over here, the browse. Okay, and then we will go to the C drive. Then okay, CS440 fall 2015. Okay, we'll go to the OP overload folder, remember in the bin debug of the project is our assembly. So once I click opoverload.exe, click add, okay, then click OK. So now if I take you to the test project, you'll see there's a references got created, and the assembly for OP overload is now part of the test project, okay? Now think of this way as if there's a box over here. So whatever classes, like the currency class that we created, is inside a box available to us. Okay, so now if I go over here in the test project and try to access currency, okay, one option is maybe it is in our project, but it's in a different namespace. Remember, if it's in a different namespace, what do? We right click and we look for resolve, but there is no resolve. So in other words, it doesn't even see the currency class, okay? And the reason is, once again, because in the OP overload, inside the box, the class currency is probably not public, because if it was public, we'll be able to see it, okay? So let's go back to the currency class. How was it declared? The class itself. Remember, the default visibility in C# is private. So normally we don't worry about it because within the project, everything can see each other. But now we need to go outside of the project, outside of the assembly. So if we wanted to be able to expose this to the outside of our assembly, this has to be marked public explicitly. Okay? So now if I mark it public explicitly, build it again. Okay, and of course the error is in our test project, so don't worry. So now you have two options. One option is you right click in the test project OP overload and remove it. Because remember, we changed it now. Okay, so I remove it. Then I right click on references in the test project and add it again. And go back to the browse button, and hopefully it remembers we had picked it up from the big bin debug folder, and I pick it up, click OK. Okay, so once we have added the reference again, OP overload, okay, now let's go try to the unit test project. Okay, so now if we try to right click, do you see the resolve is appearing at the top? Okay, and remember, the reason it still did not see directly is because currency is declared in a different namespace. If I go to the currency, the regular OP overload project, what namespace is it declared in? OP overload. What's the namespace of our test project? If I double click on unit, okay, it's a different namespace. So that's why it did not recognize. But if you have the assembly available as part of your project, which we do now, and if the class that you are interested in accessing is public, then it's easy. All you do is right click and resolve it. So once I do that, now it's being recognized. Now we can create objects of it. So we could do currency C1 equal to new currency, let's say $5.30. Currency C2 equal to new currency, let's say $3.20. So this is our very simple, oops, did I do $3.20, right? And now I will do currency C3 equal to C1 plus C2, right? And so now what is the expected result? $8.50, right? So in the test project, we have what is called an assert statement, okay? So assert is a class which has many static methods in it, okay? So if I do assert.equal, so think of an assert as we are saying we expect a particular behavior, okay? So in our case, we will say assert, let's say R equal, okay? So there are many overloaded methods over here. Okay, double delta. Okay, so for example, we are expecting 8. So 8 is the expected, right? So take a look over here. Expected is 8, and what is the actual value? The actual value is whatever C3 dot dollars is. Okay. So C3 dot dollars. Okay, comma, and then we can put some kind of a message. So, for example, I can say incorrect dollar amount. So if the test fails, meaning the answer does not come out to be 8. So this is the actual result, right? So if the amount is not 8, this test will fail. So this is how easy it is to write a unit test. So we have done a very simple, so let me just call it a simple rather than normal unit test, right? Okay, so now all we have to do is run this test and see if this test passes or not. So how do we run the test? There are a couple of ways. If you right-click on the test and just say run tests, so it will run the test and give us a visual output. Over here, if you see pass test on the left side, okay, so that means the test passed. The expected answer was same as what we did, right? So let me now add more tests over here. So typically you don't try, okay, as a guideline, you never write a test method which is more than 10 lines long. Okay, your test methods will always be very small, mostly 3-4 lines. Okay, but you will create many tests to make sure you cover all possible combinations of where the potential problem might exist. So you cover all of that. So anyway, let me highlight and copy this and paste it right below. So now let me make it a little bit, suppose dollars, or let's call it cents exceed 100. Okay, it's always a good idea to give it some meaningful name, so that, rather than saying test 1, test 2, test 3, and you wrote 20 tests, in the end test 17 failed, then you have no idea which one failed. Okay, so this way at least by looking at the name you will know. Okay, so now let's exceed so we make it $5.80, and let's make it 30 cents. Okay, so the answer expected will be what? $9. Oh, and by the way, I forgot to add one more statement over here. I only compared the dollars. I also need to check the cents, so I'll just copy and paste the same line. So cents in this case was supposed to be 50. C3 dot cents. And incorrect cent amount. Okay, so now let's go to this one also. Let me paste it below. Okay, so $8 C3 dot. Okay, incorrect cent amount. Okay, so what do we expect in this case? $9, correct? So $9 is the dollar amount, and what's the cent amount we expect? 10, correct? Okay, so anyway, if I right click on it and say run tests, okay, and on the left hand side you can see it passed, right? So you can see the test that I ran passed. Okay. Now let's do one more test where it does not pass. So if I highlight and copy this test, okay, and above the last two curly braces, if I paste that test, okay, and now let's, and rather than exceed 100, let me call it equals 100. Okay, so let me make this 20, correct? And so what's the expected now? $9, and this should be 0, right? Everybody agrees? So now if we right click on it and run tests, okay, so now let's see what happened. Okay, okay, do you see like there's a failed test over here? Equals 100 is failed. Okay, and let's see. So if you click on it, then it will tell you, you know, what was the exact reason it failed, right? Now, usually by looking at this test now, okay, you'll have an idea why it failed, okay? But let's pretend your code is pretty complicated. The test fails and you have no reason why it failed, okay? So now we need to debug and step into step by step and figure out why it didn't work, okay? So remember, we can put breakpoints. So how do we put breakpoints? Suppose we wanted to stop at this line and go into the operator plus in our currency class and see why it's not producing the right answer, right? So in this line, in this gray area, if you click, it will put a red dot over there, and that's called the breakpoint. Okay. You can always go to the debug menu and you can delete all breakpoints if you wanted to. You know, sometimes you are done cleaning up everything, so if you had 12 breakpoints, you wanted to all delete them, you can do that, right? Or you can individually go. If you clicked and set a breakpoint over here, click it again, it will go away. Meaning you can individually remove the breakpoint, right? Now for the debugger to stop at a breakpoint so that you can examine what data you have, make sure you run it once you go to the debug. You say debug, start debugging, not without debugging. If you did without debugging, it will never stop at a breakpoint, okay? So anyway, so now we wanted to debug this, right? So first thing you should do is, how many projects do we have in our solution now? Two, right? OP overload and OP overload test. So first you will do is right click on it and right click on the test project and set it as a startup project. Once you have set it up as a startup project, then go debug and start debugging. So set the overload as the project class library cannot be started directly.
It has a form.
Alright, so let me not, okay, let me go to the currency class. Okay, used to be I could debug it like this, but maybe they've changed things. So let me go to the currency class in the overload project and go to the operator and set a breakpoint somewhere in the beginning of the operator plus. So I'm setting a breakpoint somewhere over here. Okay, in the currency class, right? And now if we go, okay, let me leave the, okay, let's go to the test project. Okay, so if we go to the test project and go back over here, so if I right click on it, okay, one of the options you will see there's a debug test instead of a run test, right? So let's try this option. So if I go debug test, okay, so now you can see it ran and it stopped at this line. So it changes to a yellow color once it hits the breakpoint, okay? So anyway, now you can examine what's C1, 580, is that correct? Yes, it's 580. What's C2, 320, is it correct? Yes, seems it's correct, right? Now we wanted to go inside the operator plus to see why it didn't work, okay? So if you go to the debug menu over here, you will see there's step into is F11, step over is F10. If I hit F10, it will simply go to the next line. If I wanted to go inside the currency class and the operator plus, then I have to step into. So once again, if you forget, you can always go to the debug menu and you can see it's F11 over here. So if I go F11 on my keyboard, you will notice now it took me to the currency class, okay? So now we can go and put our mouse on LHS. Oh yes, this is correct so far. This is correct so far. And then if I hit F10, which is step over, see again, if you forget, debug, step over, meaning go to the next line. Okay, so now it stopped at this yellow line. It's hard to see, but on the computer screen, it's a nice yellow color. Okay, so if I hit F10 on the keyboard, okay, we'll go to the next line. Okay, if I go F10 again, it will go to the next line. Anytime you can put your mouse on sense, and you'll see, oh, so far so good, sense is 100. Okay. And now if I hit F10, okay, see it was supposed to go over here and add one more to the dollar amount. So if I hit F10, because 100 is not greater than 100, it will skip and go to the else part, okay? So now at least you know what the problem is and you can fix it. So you will go debug, stop debugging. Okay, so now you will go back over here, take out the breakpoint, and make this greater than equal to. Okay, so now my question is, if we build it, do we have to go and remove the DLL, the reference that we had added in the test project, and add it again? Remember we changed the code over here, right?
Yeah, we have to.
So we have to add it again, okay? So let me show you a better way to do it now. Rather than every time you go and change the code in the original project and then remove the reference, add the reference again. Okay, so let me remove the reference now first. Okay, so previously let me show you how I had brought the assembly for the currency over here. Previously this is what I did. I went to the references, I said add reference, or I went to the project and test project and add reference, either way. Then what did I do? I went to the browse and picked the DLL, right? Pick the EXE, not the DLL. Okay, pick the EXE. Okay, so instead of doing this way, let me cancel now. If I right click on references and add reference in the test project, okay, on the left hand side you will see there are 4 possible options. One is the browse that we picked last time. If you take a look at 2 above, it's called the solution. Okay, so how many projects do we have in the solution right now? 2, right? But other than the test project, there's only one other, which is called OP overload. So all I have to do is add a reference to the whole project, okay? And click OK. And the net effect is it will still get added, but now the added benefit is you go change the OP overload project, automatically it will update the assembly over here. You don't have to keep removing and adding it again. So it's a better practice to add a reference to the whole project if they are part of the same solution, okay? So rather than, but sometimes, you know, let's say this was developed by, the OP overload was developed by third party, and all they gave you was an EXE or a DLL. Then in that case, you will do what I did before. You'll browse and pick up the DLL or the EXE file, okay? All right, so now that we have brought that, right? Okay, let me build the whole solution so that everything gets compiled. Okay, now which test failed last time? Sorry, I'm not in the test project. Let me go to the unit test currency. The last test, right? This one failed? Okay, let me take out the breakpoint now. So if I right click on this test and run test. Okay, so you can see on the left side, did it pass? Okay, okay. Now when we create a large project, okay, we may have not just one class, but many classes in it. Then correspondingly in the test project, you'll again create a separate test class for each class that you are testing, right? And sometimes rather than individually right-click, run test, right-click, run test, if you go to the test menu over here, okay, you will see run, and you have several options. You can run all tests, you can take a look at failed test, not run test, pass test, repeat last run, right? So for right now, let me pick all tests. So how many tests we had created so far? 3. So do you see all 3 came out passed? Okay. Okay, so now in your case, so now once you submit any assignment from now on, it's a good practice. At least I'll make it a requirement for our currency and what was the other one I gave you? Complex number. You will create unit tests, and again, you as a good developer, you know, not just adding 2 simple things or multiplying 2 simple things and say, oh, the test passes, right? So let's talk about, for example, testing for just the adding of the 2 currencies. How many tests make sense? Okay, one was, let's go back, we did a simple one where nobody exceeds more than 10 for the 2 digits for the dollars, and it doesn't exceed 100, right? Then we did the second test over here. It exceeded 100. Then we did a third test over here. This became 100, right? Now another test would be, one of them is 0 over here. The other one is 0 over here. Or this one is 0. The other one is 0. Both of them are all zeros, okay? So you have to cover all possible scenarios, because you never know, one case, it may work for 10 out of 12 cases, but if you had programmed something wrong, and let's say Morgan Stanley or JPM hired you, you'll be fired the next day if your currency manipulation was off, right? So you don't want to lose your job. So make sure you do a thorough coverage of all possible conditions. Okay. And like I said, the good news is once you did do it, then it not only makes your code reliable, also by just running all tests, you can print out a report and verify that you developed something proper, right? Okay, so now even if you have submitted the currency and the complex assignment, please add an addition to it with the unit testing and submit it. Okay.
But why it's .exe, not DLL, the reference?
Because we created it as a Windows application. The